Hello everyone, I'm Abinaya, Assistant Professor Cybersecurity JJCET. Today we are going to see about the topic distributed computing. So what is distributed computing? We are going to see about introduction about the distributed computing. So what is distributed computing? It is a collection of autonomous processor communicating over a communication network is called a distributed computing. So what is a communication network means? It is a LAN and a WAN network. So these computers communicate with each other by exchanging messages and sharing the resources such as data storage and processing powers. So how distributed computing works? Step 1, user sends a request, and step 2, the request is divided into smaller tasks, and the step 3 is different computers process different tasks simultaneously, and the step 4 is results are combined. So step 5 is final result is sent back to the users. So real life example is a Google search. Google search is one of the best example for distributed computing. When you search distributed computing in Google, your request goes to the Google server. Many computers process the request together. So different servers search different parts of the internet and it gives the result. So many computers give one result. So another example is online shopping like Amazon and Flipkart. When you order a product, one server checks your login and another server checks your product availability and another server processes your payment and another server updates delivery details. So all computers work together to complete a one order. So motivation for distributed computing is first main motivation is resource sharing. So it shares the hardware, software, files and database among multiple users. For example, employees in your office sharing multiple data, printers, so computers and datas. Next one, high performance. High performance means divided a large task into a smaller task and execute them simultaneously on multiple computers. So example, weather forecasting and scientific simulations. So third motivation is scalability. It easily add more computers as the number of tasks or number of users or number of workload increases. Example, expanding cloud servers. So next one is reliability and fault tolerance. If one computer fails, other computer continue the work and reducing the system downtime. So example, online banking services remaining available even if one server crashes. So next one is cost effective. A group of low cost computers are grouped together. Performance similar to on expensive supercomputers. So example, small companies using clusters. Next one, support for geographically distributed users. Users in different location can access the same application and data. For example, Google Docs. Google Docs, it allows the multiple users from different countries to edit the same data. Next, improved availability. So 24/7, it have the services. So like Netflix and YouTube continue streaming even during heavy traffic. So next one is message passing. Message passing is the important topic in distributed computing. So message passing is a communication method used in a distributed computing where two or more processors exchange information by sending and receiving messages over a network. So the processor do not share memory. Here we don't have any memories. So we send or receive the messages by using the message passing. So how it works? A sender creates a message. So a sender sends the message through the communication network. So here the communication network is LAN and WAN. The receiver process receives message. So then the receiver process the received data. So process A is a sender and process B is a receiver. So process A sends a message to process B. Process B then acknowledge a message to process A. For example, ATM transaction. So, suppose you withdraw rupees 5,000 from an ATM, means ATM machine sends a request to the bank server and bank server checks your account balance. Then bank server sends a approval or rejection message back. So, ATM displays the result and withdraw your cash is approved. So example 2 is our normal WhatsApp messages. So when you send hello to your friend, your phone sends the message to the WhatsApp server. The server forwards it to your friend's phone. Your friend's phone receives the messages. So next, distributed computing versus parallel computing. So what is distributed computing and what is parallel computing? So distributed computing, it uses multiple independent computers connected through a network. But in parallel computing, uses multiple processor or cores within a single computer. So second point is computers communicate by message passing over a network. But in parallel computing, the processor communicate through shared memory or high-speed interconnects. So, in distributed computing, each computer has its own memory and operating system. But in parallel computing, all processors shares the same memory and operating system. So, in distributed computing, connected using LAN, WAN or the internet. In parallel computing, processors are connected inside the computers. So, next communication is lower due to latency. So, here in parallel computing, communication is very fast. And in distributed computing, more suitable for large scale distributed applications. And parallel computing is more suitable for high speed scientific and engineering computations. So, in distributed computing, we can continue the work. If any node is failed, we can continue our work with another one. But in parallel computing, if one node is failed, the total processes are failed. So, example of distributed computing is Google search, cloud computing and distributed databases, our online shoppings and online banking. These are the examples for the distributed computing. And the parallel computing examples, weather forecasting, image processing and matrix multiplications. So, in distributed computing, we are going to see about the topic synchronous versus asynchronous communication. So, synchronous communication means sender waits for the receiver response in synchronous communication. But in asynchronous communication, sender does not wait for the response. So, next point is communication happens at the same time. So, in parallel the communications are happen, but in asynchronous communication happens at different times. So, in synchronous communication, it is a blocking communication. Then asynchronous communication, it is a non-blocking communication. Then in synchronous communication, it is a slower to compare than a asynchronous communication. Then asynchronous communication is faster. In synchronous communication, request both sender and receiver should be available. But in asynchronous, sender and receiver not available simultaneously. So, next in synchronous communication, it is easier to coordinate, but in asynchronous, it is a more flexible and scalable. So, example for synchronous communication is phone call, video conferences, and the example for the asynchronous is mail and WhatsApp. So, advantages of distributed computing is, first one is faster execution through parallel processing. Then second one is high availability and reliability. So, third one is easy scalability by adding more nodes. Then cost effective using clusters. So, next last one is better resource utilization. Then the disadvantages is complex system design a software. So next, network communication is delays, and third one is data consistency and synchronization challenges. So fourth one is security concerns across multiple machines. So next, last one is debugging and monitoring are more difficult in the distributed computing. Thank you.